Islam Speaks, and today we are going to talk about limits. So limits is actually a very interesting and important topic because it is the beginning of calculus. And if I were to ask you what is the definition of limit, in layman's term, you would say that it represents a benchmark or a minimum or a maximum point. That's how we would define a limit as a lay person. But in mathematical terms, it simply means how a function behaves when it is particularly near to a certain value of x or y, or any values that is affected by the unknown. And of course, usually we use x to represent the unknown or the changing variable. So how do we actually write limit as? We will only use lim, and we will write the function in the middle, and we will say that when the x approaches a certain number, and that equals to the value here, which is actually the limit. Alright, so without further delay, let's look at a few examples on how to calculate limit. So the first one we'll see, say you have a limit of a function 7, and you like to count or find out the limit when x approaches 2. Now for this function, the limit is actually 7, because if you draw the graph itself, you will also see that the y is always at 7 and it's not affected by the changing variable x, because there is no changing variable x anywhere at the function. Hence, the limit itself is 7. Now let's see another example where now your function is 7x. And what happens when x approaches 2? So very simple, we will say that it is 14, because what we do is just a very simple and quick substitution. Okay, now we have our question 3. Let's look at another example here. The same thing, I will also still want to find when x approaches 2. So again, very simple, just substitute the 2 inside and you will have the answer is 15. Now let's upgrade a little bit our question to this. So same thing here, to just substitute the 2 and therefore we'll get half. Now if I'm going to change the question a bit further to look something like that. So remember previously we were doing substitution. So now if I'm going to substitute this x equals or x approaching 1 into this function here, you're going to see that I will have 0 over 0. Now we cannot find 0 over 0. Therefore we cannot do straight substitution. So what should we do? We should factorize out this function or this expression first. Okay, we have learned factorization, right? And therefore now you're only left with this x plus 1, this expression. Therefore 1 plus 1 is equals to 2, and there you go. So this is how we should do it. Okay, now let's talk about limits of infinity instead. So limits of infinity can be given as infinity and a certain expression again. So we're just going to always substitute straight away if we could. Alright, so in this case we're going to get infinity squared, and anything over infinity is actually 0. Again, let's look at another example here. Okay, so when you have 2x, or when you have x both at the denominator and the denominator, you have to pick the x with the highest power. Okay, pick the x with the highest power. In this case it's just x. You're going to end up with this expression here, and I'm going to practice the same thing, that is substitution of the x value. Here in this case is infinity, so we're going to just put infinity into every expression. Okay, and we're gonna end up having this, so the last answer will be 2. Okay, No worries, we're just gonna look at another example here. So I'm gonna have this as my example. Now let me ask you, what is the highest power of x in this question? It will be x squared. So we are going to divide all terms with x squared. Okay, so we're going to divide all terms with x squared. And now we will substitute the infinity into what we have here. So then we're going to have this. So we're going to end up having 3 over 0. What is 3 over 0? 3 over 0 is infinity, right? Alright. Now we'll move on to another section of limits, that is checking for continuity. So in order to check for continuity, you need to look at 3 things. Okay, very simple. First of all, the limit must exist. Second, I would say when x approaches c. Second, the function at point c must exist. Last but not least, number 1 must be equals to number 2. Then the function is continuous at x equals to c. Okay, we look at a very simple example here. I have a function, okay, that is bounded by the range of x. So different x, different expression. Alright, now I would like to check if this function is continuous at x equals to 1. Okay, that is my question. So what did I say the first part? We need to check whether the limit exists or not, right? So we're gonna find the limit when x approaches 1 from the left side and when x approaches 1 from the right side. So when x approaches 1 from the left side, I will look at this expression here because it's less than 1. So that I will get 5, right? And when x approaches 1 from the right side, I'll look at this one because it's more than 1, and I still get 5. So I can conclude that limit of fx when x approaches 1 do exist because they are the same. Okay, well now what about the function at that point 1? Then I will look at this one here because x is equals to 1, right? So what I get, I have 5. And this is actually equals to this here. And therefore, we can say that because it fulfills all the 3 criteria above, this function fx is continuous at x equals to 1. And there you go, different examples on this important topic named limit. Make sure you try some questions by yourself. If you have any questions, please leave comments below, and don't forget to subscribe to Miss Now Speaks. Follow me every week for more interesting topics. You can take care. Bye bye.